Alright, this is lesson 1.2 for our Pre-Calc 12 class. Unit 1 is called Functions and Transformations, and lesson 2 is called Evaluating Functions from a Graph. In this lesson, we're going to learn how to evaluate a function from a graph, and we're also going to talk briefly about what does a hole look like on a graph. What is it? What does it look like? How to identify it? What to do with it? Alright, so as we learned in the last lesson, an ordered pair, x and y value, represents x, the input in the domain, and how it's related to the y, the output in the range. The relationship between the input and the output can be determined by any given function. So in this case, the function f is represented by this curve on the graph. And we have a few points that are highlighted on our curve as just circles or filled in dots, if you will. And they're highlighted just to show you a few relationships. So I know that the point 2, 3 is on this curve. X value, the input is 2. The y value of the output is 3. So if I use function notation, I could say f of 2 equals 3. And I'm missing a line right here, so I'm still learning how to use my surface. Anyways, another point right here on the curve, the x value is -2 and the y value is +2. So I could say, using function notation, that f of -2 is +2. And for the same reason, I could say f of -6 is -3. Alright, so there's these things called a hole. A hole would be just any point on a curve that's removed from the curve. And we represent that removed point by an open circle, if you will, or this circle that's white on the inside. And so what that means is, if I put in 3 as my input, well, it looks like 3 should be the output, but there's a hole right there. So then what we say is 3 does not have an output. If I do the diagram, 3 would be an element in the domain, 3 would be an element in the range, but there'd be no arrow. No arrow would come out of 3 in the input. And so if I wanted to evaluate f of 3, my f looks funky, there should be a line right here. F of 3, there is no answer, because there's no arrow coming out of it, or saying there's a hole right there on the graph. 3 ways to say the same thing. The answer would be that f of 3 does not exist. The function f does not define what we do with an input of 3. And so we write the answer does not exist, or we write DNE. Okay, let's see here. Yeah. Some examples. So here's our graph with 5 points on it. Given this graph, f of -4 would be +3 because of point C, -4, 3. F of -2 would be -2 because of point D, the x value is -2, and the y value of the output is also -2. A tells us f of 1, x value is 1, the y value is -2. B tells us f of 3, inputs 3, outputs 3. And then E tells us f of 4, inputs 4, outputs -5. F of -6, there is no dot above or below the x value of 6. So that's not our domain, and that means that f of 6 is not defined. So our answer is does not exist, DNE. Here's a curve, it's a quadratic, fun fact. We can evaluate f of 1, f of -2, f of -3, f of 3.5, f of 5 accordingly. You just find the input value, go up or down until you hit the curve, and then find the output value. Side note, at this point in the game, looking at and evaluating from a graph, we might not always get a precise answer. So, especially in this case, we're kind of estimating some of these. F of 3.5 looks like I could estimate it's probably close to maybe 2 as an output. So I'm going to put 2. It might be really close to 2, but not exactly 2. Don't know, because we don't have a precise function definition. We're just given a snapshot of the graph. So At this point in the game, it's okay to be estimate a little bit. It doesn't have to be super precise. Anyways, last example, we're going to call this a piecewise graph. This graph has many holes on it. A couple of the holes have dots above them or below them. So if I wanted to evaluate f of -6, -5, -4, they're all going to be defined by this flat line right here on the curve. They all have the same output as -5. So our diagram would be three numbers, -4, -5, and -6, and they all have an arrow going to -5. At the x value of -2, there's a hole below it, and there's a dot above it. We're going to use the dot to define our function. The hole tells us not here. The dot tells us yes, right here. So from -2, our input, we're going to go up to the dot, and we're going to go right, and we find the output is 4. So f of -2 is +4. And I also know that I should not pick orange or yellow on my annotations anymore. Fun fact. If I pick f of -1, looks like it's about 3 as an output. If I put 2 as an input, we skip the hole and we go to the dot. 5 is our output. If I put 4 as an input, there's a hole, but there's no dot. So 4 is not in our domain, so we say f of 4 does not exist. And of course, f of 6 is going to be 3. All right, takeaways for this lesson. We can use graphs to evaluate functions. We can use continuous and discrete graphs. Discrete graphs being the dots, continuous graphs being the line or the curves. And we can use piecewise graphs, graphs where there's lines and dots and holes and whatever. And we also know what a hole looks like on a graph now. It's that open circle. And that's it.